All right, here's an example. We don't need the frequency for this one. We just need the x and the p of x. As long as we have the x values and then the probability values, we can identify the mean, the variance, and the standard deviation. So to identify the mean, what we're going to do is for each one of these, we're going to multiply these two numbers together, then add it to multiplying these two numbers together. So it's going to be 37 times 0.08 plus 38 times 0.21 plus 39 times 0.13 plus 40 times 0.27 plus 41 times 0.11 plus 42 times 0.2. Okay, and we'll do this in a calculator, and we get 39.72. 39.72. That is our expected value, okay? And now we're going to use that number in calculating the variance. So what we'll do is we're going to take each one of these numbers, 37, we're going to subtract 39.72 and then square it. So we'll do 37 minus 39.72, then square it, and then multiply it by 0.08. Plus, now we'll do that with this one, all right? Plus, now we're going to do it with this one, all right? Plus, now we're going to do it with this one, all right? Plus, now we're going to do it with this one, okay? Now plus, last one, now we're going to do it with this one, all right? And then we'll equals, and now let's go to a calculator and try this. All right, so you can see here we've got 42 minus 39.72 squared times 0.2, and we've got 41, we've got 40, we've got 39, we've got 38, and we've got 37. And we hit execute, and our variance is 2.5216. 2.5216, and now we want our standard deviation. Our standard deviation is the square root of the variance, which is the square root of 2.5216. All right, so we want the square root of 2.5216, and our answer is 1.588. 1.588. And so our variance, our standard deviation, and our expected value. Now the last thing we'd want to do with this is be able to identify some probabilities. Here's that same example. We've got 37, 38, 39, all the way up to 42 with our probabilities, right? Okay. So now let's say we want to know, well, what is the probability that x is equal to 41? Well, equal to 41 is just 41, and that's 0.11. So 0.11. Okay, well, this one says, what is the probability that x is less than 39? Now notice this does not say or equal to, it just says less than. That means we're not going to include 39. Less than 39 means 38 or 37. So all we have to do is add together the probabilities of 37 and 38. So 0.08 plus 0.21 is 0.29. And then this one says, well, what's the probability of x being less than or equal to 40? So now it's going to do everything less than 40, but it's also going to do equal to 40. So that's going to include less than 40, which is 39, 38, and 37, but it's also going to include 40. So we need all four of these probabilities added together. So 0.08 plus 0.21 is 0.29, plus 0.13 is going to be 0.42, plus 0.27 is going to be 0.69. So this will be 0.69. Remember, that is including 0.08 plus 0.21 plus 0.13 plus 0.27, okay, because it includes everything less than 40 and equal to 40, okay? And now let's do the probability that x is greater than 39. This says greater than 39, but not equal to 39. So just the numbers larger than 39. Well, 40, 41, and 42 are all larger than 39. So we're going to add 0.27, 0.11, and 0.2. So this is going to be 0.27 plus 0.11 plus 0.2. and that's going to be equal to 0.58. Okay. Last one here, this is the probability. Here's a between question. The x is going to be greater than or equal to 39, so that's going to be 39 and above, but it also says less than 42, so do not include 42. So less than 42 is 41, 40, and 39. So we're going to only include these three numbers. So we're going to include 0.13 plus 0.27 plus 0.11. And that's going to give us 0.51, okay? And so that's our example here. If we're given a discrete random variable probability distribution, we can identify the mean, the variance, the standard deviation, and any number of different probability questions.